Welcome back to the deep dive. Today, we're kind of skipping past the whole manual email sorting nightmare.
Yeah, leaving that behind.
And we're jumping straight into something, well, almost cinematic. We're talking about building your own digital assistant, moving beyond just, checking email to actually architecting a custom, smart, conversational hub for it all.
Right.
Think of this deep dive as laying out the actual technical roadmap, step by step, to get that sort of her experience, but for your inbox.
And that roadmap is exactly what we're focusing on. The sources you sent over, they lay out these technical phases pretty clearly.
Okay.
So our mission here is to distill all that information. We start with simple script automation, the basics.
Right.
And then we scale it piece by piece, all the way up to a full-blown AI communication platform, likely running in the cloud.
And the big picture here, it's not just about being more efficient, is it? It's really about maybe freedom.
Freedom from the inbox clutter, yeah.
Exactly. Forget clicking through 50 emails that don't really matter right now. We're envisioning a system that reads everything, summarizes the important stuff, tags it, high, medium, low relevance.
Automatically.
And then actually speaks those summaries to you, like a curated morning briefing. So you end up talking about your mail, not just sorting it.
A completely different interaction model.
Okay, so to get to that future, we have to start, well, smaller.
Absolutely. Crawl, walk, run.
The sources kick off with a really practical first step, just basic automated reporting, simple scripting.
Yeah, like sending a daily status email.
It proves the connection works, sure, but what's the really critical principle we need nailed down right here at the start?
Security and reliability. I mean, before we even think about letting an AI loose on your private emails,
Good point.
we absolutely have to ensure we can send stuff out securely and automatically without fail. This first script, usually Python, it just focuses on sending, maybe status updates, maybe logs.
Okay, and setting up that connection, especially for the big players like Gmail or Outlook, you hit a security wall pretty fast, right?
Yeah.
What's the one thing you just cannot skip?
It's the app password. This is like non-negotiable, a huge security point.
Right.
You should never, ever put your actual account password into a script. Just don't do it.
Okay.
Instead, you enable two-step verification on your account, and then you generate a unique password just for that specific script or application.
Oh, okay. So it's sandboxed in a way.
Exactly. If that script somehow gets compromised, the damage is limited. They don't get your main password. It keeps the core account safe.
That makes a lot of sense. That's the security baseline. Now, how do we make sure this little script actually runs reliably? Every day, maybe.
Yeah.
Without us thinking about it.
Yeah, you don't want to manually run it. You use the operating system's own scheduler. It's built in. It's reliable.
So like on Windows?
On Windows, that's the task scheduler. You just point it to your Python interpreter and tell it which script file to run and when.
And on Mac or Linux?
You'd use a cron job. It's a command line thing, but super powerful. You write a line that says, basically, at 7 a.m. every day, run this Python script.
Got it. So you're letting the OS handle the when. You just provide the what.
Precisely. You leverage the most robust tool for the job, which is the OS itself. Keeps things simple and dependable.
Makes sense. Focus on the automation, not the plumbing details, like port numbers initially. And the sources mentioned you can improve this basic setup too.
Yeah.
Even at this stage.
Oh, yeah, definitely. Once you've got it sending automatically, it's easy to make the content dynamic.
How so?
Well, instead of just sending script ran okay, you could have it say, pull some numbers from a database or read a CSV file and generate a proper daily report.
Oh, okay.
Or even just add simple logging. Did it succeed? Did it fail? Why? Makes troubleshooting way easier down the line.
Okay, let's dig into the next phase. If the AI needs to read and understand our emails, we obviously need to get them out first, not just send stuff.
Right, we need to ingest the mail now.
And for fetching mail, most people think IMAP. It's been around forever. But the roadmap seems to dismiss IMAP almost immediately. Why? Why the insistence on the Gmail API specifically?
Well, IMAP is, let's say, legacy. It can be less secure, especially for something running constantly on a server.
Okay.
But more importantly, IMAP often gives you the email as like raw, messy text, sometimes hard to parse consistently.
Right, like dealing with HTML and plain text parts.
Exactly. The Gmail API, on the other hand, is designed for applications. It gives you the email message as structured JSON data. Headers, body, attachments, all neatly organized.
Ah, JSON.
That's much cleaner.
Infinitely easier for an AI or any script to process reliably and pull out the specific bits you need. Less error prone.
Okay, so we commit to the API. What's the big hurdle then in setting up that secure ongoing connection?
It's the authentication. It's a bit more involved than just a username and password for good reason.
Okay.
You have to set up a project in the Google Cloud Console, enable the Gmail API for that project.
And then use the OAuth 2.0 flow to get permission from the user, which is you in this case.
Oof, heard of it. Sounds kind of complex.
It is initially, but it's the standard for secure authorization. The key outcome is that once you authorize it the first time,
Yeah.
the system gets back not just a temporary access token, but also a long-lived refresh token. It usually saves this in a little file like token.pickle.
A refresh token.
Yep. Okay.
And why is that so crucial? What's it let us do?
It grants persistent, unattended access. That's the magic.
Unattended, meaning the script can run on its own.
Exactly. When the short-lived access token expires, which they do for security, the script can use the refresh token to automatically get a new access token from Google without ever needing you to log in again.
Ah, so that's how the server keeps checking mail continuously.
Precisely. It's the key to making the whole thing autonomous. No manual relogins needed.
Okay, that handles getting the mail securely. But we have this stream of structured JSON data now. Raw JSON, even if structured, isn't ideal for querying, right?
Right.
You hit phase 2, store and process. Where does this data land?
Right. You need organization. You don't want to parse JSON every single time you need info. For a personal project like this, a local database is perfect. Something like Squilite. Simple, file-based database.
Yep, easy to set up. You move the key pieces from the JSON into a structured table. Think columns like .sender, subject, the clean body text, maybe the date received.
So extracting the essentials.
Exactly. This clean, organized structure in the database is really the foundation for the next step. It makes it easy for the AI to grab just the email body, analyze it, and then store the results back in the same record.
Okay, and this is where it starts to feel really futuristic, I think. The data's structured, it's accessible. Now the AI gets to do its thing, and we're talking way beyond simple keyword searching, like find emails with the word budget.
Absolutely. This is phase 3. Run AI analysis.
Yeah.
Now we take that clean body text from our database.
And we send it off to a powerful large language model, an LLM. The sources mention GPT-4 Mini as a good option.
Why mini? Is it just cheaper?
It's a balance. Cheaper, faster, but still very capable for tasks like summarization and classification. You'll need an API key from OpenAI, of course, to use it.
Right. And instead of just getting back, I don't know, a big blob of text analysis, what specific actionable things do we ask the model for?
We want structured metadata from the AI. We give it specific instructions. Ask for, say, 3 things.
Okay.
1, a concise 2-line summary of the email's content. 2, a relevance label, high, medium, or low. 3, the main topic and just 1 or 2 keywords.
So very targeted out.
Exactly. The LLM reads the email body, figures this stuff out, and sends it back. We then take those results, the summary, the label, the topic, and write them into new columns in our database, right alongside the original email data.
Okay, let's make that concrete. An email comes in, maybe from Amazon, subject, your order has shipped. My brain scans it, archives it, done. How does the AI process translate that into useful searchable data?
So the AI gets the body text, it processes it, and returns something like, summary, order confirmation for your recent purchase has shipped via carrier XYZ, estimated delivery tomorrow. Relevance, medium, topic, orders.
Got it.
And that gets stored. Now the real power kicks in. You're not limited to searching the raw text anymore. You can query the AI's interpretation.
Ah, so you could search for.
You could say, show me all emails tag high relevance and budget changes topic from the last week, or find all medium relevance emails about orders. The filtering becomes incredibly powerful and semantic.
Wow, okay. That completely flips the script. The user isn't doing the heavy lifting of interpretation anymore. The system does it up front.
Exactly. The burden shifts to the server-side AI.
And having that structured AI tagged data, that seems to be the crucial piece that unlocks the full her-style vision.
It really is, because now you have the context needed for a meaningful conversation. This lets us build what the source is called an OS-level, voice-based communication hub.
Okay, OS level, meaning it's more integrated.
Yeah, the idea is it's not just an app you open, it's potentially more ambient, more integrated, and the primary interaction method is conversation, not typing and clicking.
So let's paint that picture, the user experience. What happens first thing in the morning with this system?
It starts with the morning briefing. Imagine your system, maybe through a smart speaker or your phone, wakes you up.
Okay.
It uses a really good text-to-speech voice, something natural sounding, and it gives you the rundown based on those AI tags we just talked about.
So it might say.
Something like, "Good morning, you have 18 new emails since yesterday. I've summarized the 5 most important ones. One is flagged as urgent. It's curated."
And then it's not just a broadcast, right? The interaction goes both ways. The interactive conversation part, this is where the typing disappears.
Totally. You hear the summary, and you just respond with your voice.
Like, dude.
"Okay, archive the 3rd one." Or reply to the 2nd one with "Thanks, got it." Maybe "Remind me about the 5th email tomorrow morning."
The system just does it.
Yeah, behind the scenes, it's using the Gmail API, or whichever API, to execute those commands: archive, send reply, set reminder, instantly.
Wow. What about drafting new emails?
That's the voice drafting piece. You just tell it what you want. Draft an email to Lisa. Ask to reschedule our Friday meeting to 4 p.m. instead of 2 p.m.
And the LLM writes it?
The LLM generates a draft, probably shows it to you quickly or reads it back for confirmation, and then sends it. Minimal effort for you.
Okay, achieving that smooth, real-time voice interaction, that sounds like it needs more than just the Python scripts and SQLite we started with. What other tech components become essential now?
Yeah, you definitely need to upgrade the toolkit for this level. You
Mhm.
need excellent speech recognition, STT, speech to text, something like OpenAI's Whisper, or maybe platform native tools to accurately understand your voice commands.
Okay, captures the input, then.
You need high-fidelity speech synthesis TTS, text-to-speech for the system's voice. Again, OpenAI has options or specialized services like 11 Labs to make it sound natural, not robotic.
Got it. What about the data storage? Is SQLite still enough?
Probably not for advanced features. If you want really smart searching, like finding emails conceptually similar to something you said, you might upgrade the database. Maybe to PostgreSQL for robustness, or even a vector database.
VectorDB for semantic search.
Exactly. It stores the meaning of the text, allowing for more nuanced queries than just keywords. These components working together, STT, TTS, LLM, maybe a vector DB, that's what enables that fluid conversational experience.
Okay, the vision is amazing, but running this reliably 204/7, especially if it starts integrating with other things beyond email, the back-end plumbing needs to be absolutely solid.
Oh, absolutely. We need to think about a proper cloud architecture now, something built for continuous, secure, automated processing.
Right, scalable and secure.
We're moving away from a single script doing everything towards a more decoupled, serverless approach, perhaps. But the cornerstone, security-wise, remains OAuth 2.0.
Back to OAuth, we talked about the refresh token being key for access. How does it fit into the larger architecture as the gateway?
Its role is paramount. When the user initially authorizes your system, your backend receives that crucial refresh token. The beauty is, your backend never sees or stores the user's actual password.
Okay. Just the token.
Just the token, which represents permission. And importantly, that refresh token needs to be stored very securely, usually encrypted, in your backend database. It's the key that allows your system to keep working autonomously.
Right. So securing and managing that token is job number one for the backend.
Correct. When the user first connects, there's usually a specific function, let's call it Oath callback, that handles receiving the authorization code from Google, exchanging it for the access and refresh tokens, encrypting the refresh token.
Using something strong.
Yeah, like a Fernet key or similar, and then storing that encrypted token safely in a database, maybe like Firestore or PostgreSQL.
Okay, token secured. Now, let's trace the flow for actually processing emails continuously in this cloud setup. It needs to run constantly, but hitting the LLM for every single email seems expensive and maybe slow.
Exactly. You don't want the process of simply checking for new mail to be blocked by slow AI analysis, so you break the work up. The common pattern is fetcher, queue, and worker.
Okay, the fetcher, what's its specific job?
The fetcher is a simple component, maybe a cloud function, that runs on a schedule, say, every 5 minutes. Its only job is to use the stored decrypted refresh token to ask the Gmail API any new unread emails.
Okay.
If there are, it pulls the raw email data, just the basics, maybe sender, subject, body, ID, and perhaps stores it temporarily. Crucially, it does not try to analyze it.
It just grabs it. What then?
Instead of analyzing, it publishes just the unique ID of that new email message onto a message queue. Think of systems like Google PubSub or RabbitMQ.
A queue. Like a waiting line for emails needing analysis.
Precisely. It acts as a buffer and a dispatcher. If 100 emails arrive at once, they just line up nicely in the queue. This decouples fetching from processing.
Smart. So the fetcher adds IDs to the queue. What picks them up?
That's the job of the AI worker. This is another component, maybe another cloud function that is constantly listening to that queue.
It's triggered by the queue.
Exactly. When a new message ID appears in the queue, a worker instance spins up or grabs it if already running.
Yep.
It takes the ID, retrieves the full email body from wherever the fetcher stored it, and then it does the heavy lifting.
Which is?
It sends the text to the LLM, like GPT-4 or Mini, for the summary, relevance, tag, and topic. It gets the results back. Maybe it even generates a placeholder URI for where the text-to-speech audio file will be created later.
Okay.
And finally, it updates the main database record for that email, marking it as processed and storing all the AI-generated metadata and the TTS placeholder. Now it's ready for the user's morning briefing.
Wow. Okay, so putting it all together, and what we've designed here is a fully automated, scalable backend, secure authentication using OAuth, decoupled components using a queue. The expensive AI work only happens when needed, triggered asynchronously. It's basically an intelligence engine operating behind the scenes.
That's a great way to put it. An intelligence engine ready for reliable, continuous operation. Hashtag, tag, outro. So I think the final takeaway here is this whole framework, it really does transform email. It stops being this constant digital chore, this burden you have to manage,
Right.
and it becomes something else entirely, a powerful conversational interpretation system. We're layering intelligence using voice on top of secure, structured data. And in doing so, maybe making digital communication feel a bit more human again.
Yeah, it completely reframes the interaction. We've mapped out the technical path from simple script to full AI backend. You're really not checking emails in the old sense anymore. You're talking to your digital assistant about what's actually going on.
Dynamical shift.
So here's a final thought to leave you with, something to chew on. This whole foundation we've discussed, integrating the speech-to-text, the LLMs, the text-to-speech, all tied together with secure APIs. It's clearly powerful for email. But once you've built this kind of robust intelligence layer, what else could it transform? Think about it. Your Slack messages, raw meeting transcripts turned into summaries, calendar management, maybe even creating personalized audio digests of videos you don't have time to watch.
The possibilities are huge once that core engine exists.
Where else could this conversational OS take over? That's something to think about.